Hello learners, welcome back. Today we're going to finish talking about the three main types of soil: sand, clay, and silt. If you remember from last time, each of these different types of soil has some different properties, namely in the size of their particles and the hardness of their particles. If you remember, sand has very large particles that are very hard. Silt has medium-sized particles that are of medium hardness. And finally, clay has the smallest particles that are the softest. Now, if you remember from our last video, we talked about how these properties change the way water behaves when we add it to these soils. If you remember, the water would go right through the sand, it would sort of hold in the silt, and it would hold a lot of the clay. So let's take a closer look at how that works. Okay, so we've got a good little pile of sand here. Now I'm going to use my dropper, and I'm going to fill it up with some water, and I'm going to add some of these drops of water. So what is happening to the sand? Well, first of all, we know that it actually makes the grains sort of stick together. Look at that. Now I can just move that wet part, and everything else will stay where and all the dry part will still stay, but I can just pick up, well, sort of, I can pick up this wet part, right? It turned into almost a solid piece, but if I push it, it'll still come apart, but the pieces still stick together. Well, that's because the water gets in between the little grains of sand and sticks to them, and then water sticks to itself. So this allows for some water to stick in between them, but if I feel it, it still feels kind of rough, and I can still feel the grit and that larger particle size as I roll it around in my fingers. And I can just brush it off. And well, it's a little bit wet, but if I just brush off my hands, most of that sand will go away. Okay, so that shows that it has a pretty large particle size that still keeps a lot of its properties even when it's wet. All right, next up, let's have a look at the silt. Let me pour some out here. All right, now I'm gonna add some water to the silt, and look at that. It looks like the water doesn't really want to mix, does it? It gets some of the pieces on it, and then it sort of just rolls away. So if I wanted to really mix this together, I would have to mush it to make some mud. And then it starts to get kind of sticky and a little bit goopy like mud, as you can see here. Okay, excellent. And then finally, let's look at some clay. So let me see if I can get some clay out, and oh no, it's in giant pieces. Those particles are big, so let's crush them down a little bit. Now remember, clay is very soft, and that's why I can do this with just my fingers. I can crush down all these larger pieces into smaller pieces. All right, now let's add some water. Now, as we mix it, this starts to feel kind of sticky on my fingers. It's almost like I can't get it off of my fingers. And it's very kind of slimy, and it's very sticky. As it sticks, it's getting into my fingernails. This is very different from the sand, which I was able to just brush off. This is not brushing off anywhere. This is very sticky, and it has really stuck to itself as well. That's because the particles of clay are so small that they lock together when the water gets in there. And this will let the clay be very heavy and thick and gooey and sticky because of those small, soft particles. All right, I need to go wash my hands, and we're gonna do one more experiment. So when I had the sand in this first cup, if we imagine that we're looking very closely at it, we know that those grains of sand were kind of large. And that means that because they're so large, there's space in between them for the water to go down and through. Now, if you remember when we looked at how the sand behaved when it was wet, we noticed that a lot of it would, that the sand ended up being very sticky to itself. That's because after the water has left, these sand particles are each a little bit wet. And as we know, water likes to stick to itself. So all of these will be sticky to each other. That's what allows us to make sand castles, because those little grains of sand, once they're wet, will stick to each other, but water can still flow right through them because there's space in between, due to their large size. Next up, we had the silt. And the silt had medium-sized particles that were all facing in different directions, because remember, silt is made out of soil, which is a lot of dead plant stuff, dead animal stuff, and all that. And water could flow pretty well through these, not as much. And as it went through, these would stick together and that would create that mud. So we had some flow, but it would also hold some of the water. It's about in between. It doesn't let as much water flow out as sand does, it still holds some, but compared to clay, it holds more than, it'll let more water through than the clay will. And that's because those clay particles are so tiny. When the water tries to go in and that clay gets wet, all those little particles will just stick together, and then the water can't really come down through because the clay will hold so much water, and those particles are so small and soft that they just get very sticky, if you remember from the video. So what we're going to do is we're going to set up a little experiment that shows us which of these will be better for growing a plant. Okay, for this experiment I have my 3 trays set up. Here I have my sand, my silt, and my clay. Now what we're going to do is I'm going to put a bean in each of these. I'll have a bean in my sand, bean in the silt, and bean in the clay. And I'm going to push them in, cover them up, planting each one exactly the same. And then I'm going to add some water. Here's the sand, the silt, and the clay. All right, and we can already see how each of those is behaving a little bit differently. The sand, the water that I put into the sand is already gone. The silt and the clay still holding their water. All right, so go ahead and make your predictions about which one will be the best at growing the bean. All right, friends, I hope that you learned a lot about the different types of soil, and when we come back from fall break, we'll check in on our experiment to see which of the 3 types of soil will be better at growing a bean. You guys enjoy your break, and we'll see you soon.